Good afternoon and good day, everyone. Thank you for joining us. Welcome to the webinar on networking for AV professionals. Let me introduce the team. Today's presenters are Anish Samuel, which is myself. I'm from the system application team at Shure, Middle East and Africa. Joining me is Ritendra Podar from the systems application team, Shure, Middle East and Africa. Discussing the ground rules. Today's webinar platform is on BlueJeans. Participants' video and microphones are muted, so please ensure that it remains muted throughout the webinar. We would recommend to you to wear headphones or earphones for a better quality audio experience. And please feel free to type in your questions in the chat or the Q&A box, and we'll answer at the end of the session. Thank you in advance. To touch upon the webinar setup for today, as we are aware that many people are currently working from home, and most of our work are involving conference calls via Skype, BlueJeans, Teams, etc. We all can agree that audio plays a very important role. So, if during a video call, the audio is still there and the video fails, you can still continue the call. But if it is the other way around, there's no way of continuing the communication. So clear audio is therefore a must for effective communication. Otherwise, joining parties need to stress a lot to listen to the conversation, which is not good if the call needs to go on for hours and hours. So it also affects the productivity, as the conversation is not going to be clear and participants will not be able to understand what is being conveyed and will start joining the dots with guesswork. So as Shure, as you may know, that we have more than 90 plus years experience in delivering quality audio products. And we would like to reiterate that clear audio is a must in effective communication. So to have the effective webinar, we have done our home office setup with Shure Motive product line, which we would like to introduce you. So right now, I'm having a Shure MV51 microphone connected via USB with my laptop. So I also have a headphone and a USB camera as well. Ritendra has a Shure MV5 digital condenser microphone connected via USB with a Shure SRH 145 connected and a USB webcam for video. A quick look on Motive key features. The setup is very easy. It supports plug and play, so no drivers are required. You have a 3.5 mm headphone jack built in for audio output. And it's compatible with smartphone, PC, and Mac. The DSP functionality is already built in. You can have limiter, compressor, and equalizer functionality. The MV5 supports 3 DSP preset modes, which is vocals, flat, and instrument modes. And MV51 supports 5 DSP preset modes, which is speech, singing, flat, acoustic instrument, and loud mode. So it offers seamless integration with AV applications and soft codec like Skype, BlueJeans, Teams, etc., which are quite important for today's home office kind of setup. Moving on, the MV5 offers flexible mounting options with its microphone standard threading. Same goes for the MV51, which offers flexible mounting options as well, with its microphone standard threading. So it also has a durable touchscreen front panel to ensure that the unit is long, it has longevity. Moving on to today's webinar. Today's webinar, is focused on networking. So networked audio has become the new normal in many installed AV systems. But IT departments often need the reassurance that it won't disrupt the enterprise network. So you need to reassure the IT team at all point of time before a project and after a project. So there are a number of potential pitfalls that a system integrator can avoid with a little knowledge and preparation in advance. So we'll discuss what the IT department needs to know and how to ensure a smooth install and commissioning from your side. So to reiterate, this webinar is just only a basic overview and it is not a certification program for networking. So this would only ensure that you as an AV professional will have the necessary basic know-how on how to communicate with an IT personnel. So in case of any discussion on prerequisites, issues, best practices, troubleshooting, etc. of Shure products. So today's webinar is structured as followed. You have the module 1 as hardware and standards. Module 2 is IP addressing. Module 3 is networking your computer. Module 4 is networked audio. Module 5 is flows versus channels. Module 6 is switch configuration. And the last module is the top 5 problems that you can face in today's AV scenarios. So we move on to the first topic, hardware and standards. So here we are going to touch on the transmission methods, the cables, RJ45 connectors, switches and routers, bandwidth and topology, which are all part of the hardwares and standards. So transmission methods. So basically there are 3 modes of transmission methods that we are going to discuss about, which is unicast, multicast, and broadcast. So unicast. What is unicast? Unicast is one-on-one communication. So that means one sending device and one receiving device. So if you need to send the data to multiple receiving devices, you need to send the packets again and again. So every time the transmission is done to multiple devices, a sender has to resend the data or the message to each device. So just bear in mind that we are going to discuss about Dante audio networking, and Dante audio networking flows are unicast messages by default. Just bear that in mind, and we'll be covering that in the upcoming slides. Moving on to multicast. Multicast is one-to-many communication, where a source device sends a packet, and that packet is being shared to a logical group of devices. So what is the benefit of multicast? So the benefit of multicast is that it can improve network efficiency. That is, multiple RX units are listening to a single TX unit. RX and TX being receivers and transmitter unit. So multicast is much more efficient. You don't have to send the same data again and again. But the flip side is this is more work for the switches that are handling the data transmission, and you also need to consider bandwidth if the service is being shared by other if the multicast network is being shared by other services. Moving on to broadcast. So what is broadcast? The broadcast is the packets are addressed by special broadcast IP addresses and sent to the entire nodes or devices that are connected in a network. So information is effectively shared with everyone. So what is the key difference between multicast and broadcast is that multicast is the packets are received by requesting RX devices or receiving devices. However, broadcast packets are received by all the nodes within a connected network. Moving on to the cables. So why we are going to discuss about cables is that, just like audio or analog cables, 90% of all issues are solved by generally checking cables. So, we need to make sure that it is always better. The cables that we choose are always better, and it is apt for the application. So some of the key cabling, categories that we are going to discuss is Cat5, Cat5e, and Cat6. So the difference in these categories are basically the network speed. So Cat5 can support up to 100 Mbps or megabits per second. Cat5e can support up to 1 Gbps, and Cat6, 10 Gbps. So as the category keeps on increasing or improving, there is, an improvement in speed and also the crosstalk. So what is crosstalk? So crosstalk is actually a disturbance caused by an electric or magnetic field. So when one signal is passing through a cable, and it shouldn't affect the adjacent circuit. So The crosstalk is that kind of disturbance, and it is improved when you go categorically upwards, like from Cat 5 to Cat 6. It is much improved. And you need to make sure that, if you're following a certain category, like a Cat 6, and if you're using it in a 1 Gbps network, so because Cat 6 can support up to 10 Gbps, and if you're using 1 Gbps network, it won't be technically an improvement. So you need to make sure that the categories are followed right from the cable to the switches and all the nodes in between. So moving on, the Cat 5 and Cat 6 use twisted pair for data transmission, and the version E in Cat 5e is the terminology called as enhanced. So it imposes more stringent crosstalk requirements. So when data is being transmitted in a single pair, it doesn't affect the data that is being transmitted in the second pair. So that's why it's much better when you go towards categorically upwards. Moving on to the RJ45 connector. See, the RJ45 or the RJ stands for registered jack. So it is a standardized networking interface or Ethernet connector. So each RJ45 has 8 pins, and RJ45 cable can have like 8 separate wires. So you can technically, if you look at the end of an Ethernet cable, you can actually see the 8 wires, which are of different colors. Like 4 of them are solid colors and 4 of them are striped colors. Moving on to the shielded RJ45, it is a de facto requirement for like networked audio, because the shielding is required in a situation where you need excellent rejection of electromagnetic interference or interference due to outside elements. So once you do the shielding properly, it is the outer casing is metal and it is properly isolated, and the data is transferred properly. So you need to also make sure that the tab on the top of the connector, so it shouldn't break off, while you are handling the jack, so that the cable doesn't come out and cause network related issues. Moving on to switches and routers. So switches and routers are normally used to network multiple devices together. So basically, like they come in different form factors and also different flavors. Like it can be a consumer model or a professional product. So technically, what you pay for is what you get. So it is important that quality products should be used for quality or professional results. Okay. And each of these switches can also have additional features like wireless, DHCP, PoE, etc. What is the most basic explanation of a switch? The switch is actually designed to connect computers or network within a local area network, while a router is actually meant to connect multiple networks together. So as you can see, local nodes are connected to a switch and they can communicate with each other through the switch. But if you need to connect to an outside network or the wide area network or internet, you need to have a router. So even though routers and switches are different, they can also be used interchangeably. For example, a router, typically has several LAN ports and a single WAN port to connect to the internet or WAN. So moving on to the topic of bandwidth. So what is bandwidth? The network bandwidth is actually the capacity of a wired or a wireless network. Its capacity to transmit maximum amount of data from one point to another point in a computer network or an internet network, within a given amount of time. So usually in 1 second. So bandwidth is effectively the data transfer rate in terms of capacity. So taking this following example, we can easily explain the benefit of having better bandwidth. So say for example, 1 Mbps is equivalent of a 1 lane highway. And let's say that you are trying to download an image, which is like 5 MB in size. So if you have a bandwidth of 1 Mbps or the 1 lane highway, it would take you roughly 5 seconds to download the image. So now let's say that you have a 5 Mbps bandwidth connection or a 5-lane highway. So how fast will you receive your image? 1 second, right? So what is important to note here that the internet is actually not becoming any faster from 1 Mbps to 5 Mbps or even more, more bandwidth. Your data is just getting transferred to you at a faster rate because more data can be sent, technically at the same time. And it is only the perception that the internet is becoming more faster, while technically it is not faster. It is like, you are getting the data more faster. So it is always, important to note that the pipe should be large enough to fit the information and the requested data. So moving on to the topic of topology, so we are going to discuss about daisy chain topology here. Daisy chain is actually an interconnection of computer devices or peripherals or network nodes in series, like one after the other it is getting connected. So, here we are taking an example of a couple of Shure ULXD receiver units. So the laptop can communicate with the ULXD unit as it is interconnected with each other, one after the other. An important thing to notice is that, if the communication breaks in between, the nodes following the broken chain will not be accessible anymore. So if there is a breakage in between, the nodes that are following the breakage, it won't be accessible for the laptop anymore. So even though this is a cost-effective and a simple to deploy kind of topology, it is not recommended or it is not efficient in many of the applications. So moving on to the star topology. Star topology is more of a local area network, most common topology of a local area network where all the nodes are individually connected to a central connection point like a switch. So you can see a switch which is acting like a common highway for all the data that is coming. So each host may thus, it can communicate with all other hosts by transmitting to and fro from the central hub. So the failure of a transmission line, linking to any particular host will not affect the host, the rest of the nodes in the network. So what are the advantages of such kind of a connection? So if one connection break, it doesn't affect the other computers in the connections. And it can work quite well in heavy load, and it is very appropriate for large networks. So devices can be added or removed without disturbing the network. What are the disadvantages? So there is only a single point of failure, like the central hub is a single point of failure for the network. And it is quite expensive, at times due to the number and the length of the cables connectors. So moving on to IP addressing. So we can take an example of IP addressing as like taking a typical neighborhood kind of scenario. Like you can address cables as the roadway, and switches and routers are like intersections. So what is IP address? So IP addresses are like the mailing address. So in effect, if somebody wants to deliver a mail or something, he has to check the mailing address first, then take the appropriate roads and intersection to reach a particular destination. So what is an IP address or an internet protocol IP address? It is nothing but a numerical label which is assigned to each device which is connected to a computer network that uses IP for communication. So effectively, the IP can give us it can serve two main functions. The one, it identifies the number of hosts or the network identification of a particular network, and also it helps in location addressing. So we are going to touch on a couple of definitions and terminologies as we move forward in IP addressing. The first topic is MAC address. The MAC address is nothing but a hardware address or a organizationally unique identifier. So it is like your unique government issued ID for an individual. Like every device that is connected to a network will have a unique ID to it. So it's nothing but a 12 hexadecimal characters. It supports hexadecimal characters, where the first 6 characters are like vendor specific. So if you see this example, 38EAA7 stands for HP. So it makes sure that the Ethernet is associated with HP, and 857758 is the unique identifier for that particular device, which is a part of the network. So why is MAC address important? So when we talk about a communication between a local area network, or I would say like layer 2, referring to the OSI layers, which is a slightly advanced topic, and which wouldn't be part of this particular webinar. But when you have a communication between layer 2, it is happening over MAC address rather than IP address. So we'll discuss in more details going forward. So what is an IP address? The IP address of a network device is simply the device's address on a network. And it is comprised of 4 numerical values or octets. So each octet can range from 000 to 255. And it should be unique per device, or we can say per subnet. So one node or appliance per network should have one IP, one unique IP. So next we are going to touch the topic of private IP ranges and public IP ranges. So what is the difference between a private IP range and public IP range? Public IP is when you are communicating over the internet, when 2 devices are communicating over the internet. And when you are discussing about private IP ranges, it is actually reserved for devices that are not directly connected or accessing the internet. So it is generally used to assign computers within our private space without letting them directly exposed to the internet. You can say that it is for your home office or office. Before your connection with the internet, it is only for your internal communication. So it's applicable for local devices that come before a router. So why is private IP ranges being used? So it is used as a logical destination or endpoint in a local network, and it can vary in size. So there is a terminology called subnet mask that dictates the number of hosts on a network. So the number of hosts is the number of users or endpoints that can be part of that network. So in that regards, there are three or more subclasses that they're classifying the networks based on the number of hosts. The most common that you see is 192.168.0.02, which can give you like 254 hosts, and the class B is 65,534 hosts. Class A is 16 million hosts. So depending on the size of the network, it is being assigned. Moving on, what is a subnet? A subnet is a logical subdivision of an IP network. So basically, it is sub-networking your IP range. The device, a device that is following a certain subnet, it can communicate between this network. So the practice of dividing a network into 2 or more major networks is called subnetting. A typical example that you are seeing in your day-to-day life, it's like it is similar to what you see in IP. Whenever you are going to set an IP, you can see the subnet mask. So it is an identifier of what kind of a network you are connecting to, and depending on the network that you are connecting to, it will lead you to choose one subnet over other. So the least significant octets are actually opened first. So if you see for these 2 examples, there are changes in the last. There are 4 octets for this particular schema. So this is 1, 2, 3rd, and 4th. So when you are evaluating a number, the least octet is first being evaluated, and then it moves backwards. So 4, 3, 2, 1. So it is how you identify. So say, for example, 255.0 offers 254 hosts. So technically, like you can see in a 192.168.1.0 scenario, 1.0 would be your network address, and 192.168.1.255 will be your broadcast address. These two are reserved IP addresses in that range, and the rest of the IPs, like the 254 IP addresses within that range, will give you the entire 254 hosts. And what do you mean by a zero on an octet? So zero on the octet represents variations on the network. So more octets open or having zeros will represent more hosts on a network. So say, for example, you're seeing a schema like this, 192.168.1.1, which is a network identifier. And the subnet mask is 255.255.255.0. So technically, in order for another device to communicate within this range, you need to have a match on the first 3 octets, and you can have a change on the last octet, which is identified as 0 on the subnet mask. So 0 on the octet represents variations on the network, and more octets open having zeros, represent more hosts in a network. So say, for example, you have 255.255.255.0 as a subnet mask. So if you see, the first 3 IPs are having the first 3 octets same, and the last octet is being changed. So effectively, they can communicate with each other. And if you see the last IP address, it is having a change on the 3rd octet. So effectively, it cannot communicate with the rest of the devices, because this particular subnet mask only allows a change in the last octet. Same is the case of a different subnet mask, which is 255.255.0.0. So it allows you a change in 2 octets. So technically, you can have change in the first 2 octets, and the first 3 IPs can technically talk to each other. And the last one, because it has a change in the 2nd octet and it is not matching the subnet, it won't let you communicate with the rest of the IPs. Moving on to the topic of subnetting. A subnetwork or subnet is actually a logical subdivision of an IP network. So it is the practice of dividing a network into 2 or more networks, which is called subnetting. So what are the benefits? It's like you are being given a range of IP address like 192.168.1.1 to 1.255. So you technically have around 254 hosts. But what if your company has like 3 divisions and you need to segregate them? So you can do that with subnetting. So basically, by changing the subnet mask, you can actually reduce or divide a particular network evenly. So the benefits of subnetting are like, it can improve network performance and speed. It can improve the network congestion. It can boost network connectivity, and it can even control network growth. So you can easily identify what all devices can be added and removed from a network, and there is much control and over the administration as well. So when you take the example of a smaller and a larger network, a local network will typically have one subnet. And it's more smaller and self-contained networks of gear like switches. A basic switch would do the functionality of a local network, and everything is within a given IP range, and a basic router switch configuration is okay for a local network. But if you move on to a distributed network, or like multiple subnets are involved, the solution will be a larger distributed network of gear, like different switches connected across different segments, and then it's all routed with each other using a router. And different subnets divide and organize devices into separate IP ranges by location, or maybe by application, or maybe by a different function, etc. And if you have to communicate between these different subnets, you need to have something like a router or a layer 3 switch. because you are segregating the network, and again, if you need some kind of a communication in between, you need to route using a layer 3 switch or a router in between. So examples of a local network, it's like a touring rig or a small installation or houses of worship. So it can benefit then, definitely from automatic discovery, and devices, simply plug and play is much more usable in this kind of scenario. But if you go to an enterprise network like a educational campus or a government facility, corporate enterprise or multi-venue studios, it requires much more additional configuration, and connecting devices to software applications. It may require some configuration, and some amount of IT knowledge is required for. A huge amount of IT knowledge is required for that. So how do we get an IP address? So there are typically different ways to get an IP address. So one can be a static IP, another can be DHCP. So static IP is actually a dedicated IP that has been assigned to you. So you can use that. If you go to the DHCP route or dynamic host control protocol, so it is an IP address that is automatically chosen for you from a pool of IP addresses. Those pool of IP addresses can be in a server or in a particular scope that you have assigned, and it is available in your network. Okay, so static or dynamic. So there are certain cases where the DHCP server is not available in particular network. So your device effectively shouldn't go out of the network if the DHCP server is not available or a static network is not available. You still need to configure it. So there is a property called as link local addressing, which is mostly assigned automatically through a process called as stateless address auto configuration or link local addressing. So it effectively gives you an IP that can work on a local network or a communication within a single broadcast domain or a network domain where the host is connected to. So what is explaining DHCP? We can take an example of the Shure AXT620, which is the Axion switch. So it has a built-in DHCP server, which takes care, it automatically provides assigns IP, like default gateways and other network parameters to client devices. So say, for example, a receiver is requesting an IP, and if the DHCP server is on for the network switch, it receives an IP and uses that IP for its configuration. So the Shure AX620 Axion switch has a built-in DHCP server which can be turned on and off from the front panel switch. So imagine a scenario when you don't have the DHCP turned on the switch. So and your host device, your node, is requesting for a IP, and it doesn't get an IP since the DHCP is off in your network. So it waits, and finally, it sets itself a link local IP address that we had discussed before. And, this is just to make it accessible, even if there is a DHCP server not present in your network. So what is the benefit of having a static or a dynamic? Neither is actually better in any objective sense. And, it can be better for certain purposes. So static IP can actually provide you with specificity and predictability to an extent, because you know the IP and you can utilize it and you can reach it by a fixed IP and like that. And DHCP is like, it is managed automatically because devices can come and go, on a network on a regular basis. And it is more like a address pool, and it is being assigned, IPs are being assigned on a first come first serve basis. So it is more effectively utilized. The pool of IPs is more effectively utilized. So moving on to the VLAN. So VLAN is actually short for virtual local area network. So the VLAN can be explained with the following pictorial. So imagine a couple of computers are being shared using a single or multiple switches. So each computer, when it wants to communicate, it sends the data across all the sharing computers. which is not a very ideal scenario when you have like different segments in your company, like accounts or finance, or you necessarily need not send data between all these, and traffic congestion is resulting when you are sending data between all these. So that's why we have to go for VLAN. So VLAN is actually a logical network that can group users or devices regardless of their physical locations. So VLAN is normally created in the switch. So as you can see in this particular picture, what is happening is, a couple of workstations are tagged in such a way that they can only talk to each other. So effectively, it is dividing the broadcast domain. So even if you have a single switch, the broadcasting is happening only between these three devices, and the rest of the devices can talk to each other. So another way of representing this is the same switch is technically or logically split into two separate switches or VLANs. But this is only a logical split, not a hardware-based split. So why VLAN is important is that it provides segmentation in the broadcast domain. It reduces traffic congestion. It mitigates security concerns. So it simplifies the network design and deployment, and it is easier to troubleshoot and manage. So similarly, when you take the example for an audio schematic, you can see that different VLANs are set for management, network, and audio over Dante, etc., etc. And it will relieve, network congestion. So it's all tagged in different colors. So it's recommended. So what to tell to the IT department? So for a project, what has to be coordinated with an IT department? You need to tell them like how many devices are being connected or deployed, how many IP addresses are required, which devices are on which subnet, static or DHCP mode of IP addressing is recommended. So all these information you need to provide to the IT in advance. So if you visit shure.com/FAQ and search for 5415, the tag 5415, there's a ready reckoner chat that can actually aid in discussing project-related prerequisites with the IT team. So this would further support you in having the project deployed at a organized fashion in advance. You can also mention that the Shure audio products, the data, when you take the data, the communication is very, very, very less. The consumption or the bandwidth consumption is very less. It's less than 0.02 of the gigabit network. And with Dante, I would say like it's more or less 1.28%. And most of our devices support VLAN and ports and protocols. All of this information you'll be receiving from the FAQs page. And Dante, regarding Dante, Dante is it follows unicast by default, and peer-to-peer clocking is required for multicast discovery and effective multicast communication, which will be discussed in much detail in the forthcoming slides. So also you can refer the Shure FAQ page for keywords 4930 and 4618. So it can give you an idea of the network ports that need to be opened for effective communication of Shure devices. So what do you technically mean by a network port? Is that just like an IP addresses identifies a particular computer, the network port identifies a particular application or service running on a computer. So say, for example, a Shure device on a network, is having a web browser, and you need to access the web browser via port 80. And if that port 80 is blocked, so technically HTTP is being blocked and you won't be able to communicate. So this is to have an idea about the protocols, the TCP, IP, or UDP mode of communication. You may have to refer the OSI model, which is a slightly more advanced topic, which we would not be discussing as part of this webinar. But there are many online tutorials that are available for that. So to sum it up, the use of ports actually allow computers or devices to run multiple services and applications in a network. And turning off any of these ports, which it will block the listed functionality of a particular network device when it is being accessed by other device. So moving on to the topic of networking your computer. So we'll be touching a basic overview on how to connect your computer and what are the network interfaces and how to get your computer IP address. The first thing that you need to keep in mind is whether you're connecting a single device, whether it is part of a network of devices, or like whether it is a standalone, it is being connected to a standalone network or an administered network. So if it is a single device, it is relatively a straightforward connection. You just have to wire it directly. I mean, there's nothing much to it. If you're going to an enterprise kind of or a corporate kind of scenario, you need to understand what kind of a topology that you're connecting to. It's good to know. And the type of addressing scheme, whether it is like static or dynamic, or whether it has to be it is a standalone or a corporate network. So all those information you need to have in advance. So what is a network interface? So this network interface is nothing but a route through which your computer connects to the network. The simple explanation is that. So it can be through Wi-Fi, Ethernet, or any other mode of connectivity. So how to find your computer's IP address? So basically you need to go to the control panel of your respective system and check for preferences, or you can directly access it from the command line. Imagine if you're using a Mac, you can use the if config command from the command prompt, or if you're using Windows, you can use the IP config command from the command prompt. So it'll show you the Ethernet adapter and the IP address and the subnet mask and all of that. The Mac, the adapter, and the IP address. Windows. This is very important. So moving on to the topic of networked audio, I'll hand over to my colleague, Mr. Ritendra. So he'll be taking you through the rest of the topic. Thank you for your attention. If you have any question, please feel free to ask in the Q&A or the chat box. Thank you.
Thank you very much, Anish. Thanks for sharing this knowledge. Hello, everyone. I'm Ritain. I'm also from application team. I'm pretty much sure that in this webinar, we're going to have a mixed crowd, and a couple of them are going to have the knowledge of IT already. So for them, it's good to have a kind of refresher, and those who are new with IT, it's a good knowledge to share with them. So let's start with our next topic, networked audio. So over here, we are going to talk about digital audio. So what's the digital audio? Digital audio is a conversion of analog signal in digital representation, and it is capable of carrying multiple channels of audio via a single connection. So as I'm going to explain what happens with analog and what exactly you can do with digital signal. And it also allows for easy routing of multiple sources and destination. I'll take you to the example of 8 channels of audio. So if you talk about analog, here in this slide, we are showing our ULXT receiver. ULXT receiver can offer you 4 channels of microphone, and here it offers the analog connection. So if you have 8 channels of analog audio, so you need to route individual analog cable to your mixer or the DSP. So these cables are standard audio cable, which can be expensive. And of course, you need to run a lot of cables. That becomes messy if the proper cabling has not been planned. Talking about 8 channels of audio in digital, I'm going to take example with Dante. So if we use an audio networking protocol such as Dante, we can connect 8 channels of audio via Ethernet cable using Ethernet switch. And it's pretty much simple. Same receiver, ULXT receiver over here. And now in this particular setup, we are just using single Cat5e or Cat6 cable to connect with the network switch, and the audio channels transmit through the switch to the receiver. So it's just a matter of having 3 cable, and As Anish was explaining about daisy chain kind of topology, these receivers supports daisy chaining as well. So you can have loop in and loop out, and that can go with one single cable connection with the network switch. So it makes it simple, and everything is going to be done with the with the software using Dante controller and all, right? Why Dante? Our system supports Dante protocol. Dante is layer 3 audio protocol. And why Dante? Because Dante is gaining market share like anything. More than 1,000 third-party relevant Dante IO devices are available as of today, over 350 manufacturers. In this slide, as you can see, we are having different different microphones from us, and connection with any mixer's DSP is very simple because Dante is just the open protocol, and name any brand as of today means they are supporting Dante. So it becomes quite easier. So we are not brand specific. Any brand which supports Dante, you can route the audio channels via our microphone, right? So what is Dante? Dante is layer 3 audio over IP protocol. It's developed by Audinet. So Audinet is the company who has developed this protocol, and the protocol is license-based. They supply chipsets to the manufacturers, right? And we implement those chipsets in our devices to get the Dante audio out from there. Benefit of having Dante is like redundancy. So imagine if you have analog system and you want to have the redundancy, you need to add additional hardware. If you want to have the audio to split in multiple outputs, so at that point you need to add additional analog splitter. But with Dante, it makes it easy. You just need to go to the software, and depending on the number of flows what it has, you can have as many as channel you want. So I'm going to quickly talk about the major features and benefit of Dante. So Dante is uncompressed. It offers multi-channel standard with near to zero latency, yeah, and tight time synchronization. Supporting multiple sample rates, you can set the different sample rate what you need for your receiving device, and different latency at the same time. Latency is 100% deterministic, always known and consistent. You can monitor what's the latency of the system. You can change as well, right? Dante works with most of the switches. You buy any switch and you connect and it will work. But of course, when we are talking about the serious Dante installation, then you need more, much advanced switch, which we will talk about in this webinar. Yeah, Dante is layer 3 protocol. The communication between Dante devices happen through IP addresses, and Dante also offers you sub-protocol like QoS. QoS is quality of service. We'll talk about quality of service as well. Other benefits, what we can talk about is Dante integrates media plus control for the entire system over a single Cat5e, Cat6, or fiber cable. Yeah, so talking about multiple channels, you can have with single Cat5e and Cat6 cable. Easy to scalable for up to 1024 audio channels in unicast or multicast traffic. Easy to control via Dante controller. So Dante controller is a software using which you route, you control the Dante devices. Also Dante virtual sound card and Dante Via are other software from Audinet. User-friendly devices and channel names. You can have user-friendly names for your devices. When we talk about large installation, you'll be having multiple Dante devices. So it becomes quite easy when you have a specific name for different area or the location. So that's what you can do with Dante. And auto discovery of devices when entering the network. That's another benefit. You're not going to lose your hardware if it is having the Dante protocol included. So you just connect the device through the network switch, open Dante controller software, and it will discover. If you're not on a same subnet, you will not see in this front main page, but you can see in the network page where it will show what is the IP range defined for that Dante device, and you can change the IP and get it. Talking about a couple of Dante facts. So, and these are important, which you need to understand. Dante doesn't need its own network. You can use your existing infrastructure, network infrastructure, to run Dante audio packets in the network. Yeah. So talking about, as Dante is layer 3, so it is possible. Now, I can give you a couple of examples where when you talk about layer 2 base audio protocol like AVB or CobraNet, they need separate IT infrastructure, separate infrastructure to run the audio packets through the network. But Dante can accommodate your existing infrastructure. So it is a great benefit of having Dante. And Dante won't slow down the network as well. To give you an example over here, in this slide, you see there is a table, channels. So 4 channels, 16 channels, 64 channels. So let's see how much bandwidth and percentage of data gigabit link is going to be consumed by Dante audio. So for 4 channel, bandwidth is like 6 megabits per second. For 16 channel, it's 24 megabits. And for 64 channel, 96. Yeah. And the percentage of switch processing is like 0.6%. For 16 channel, it's going to be 2.4. And for 64, 9.6%. So all these information, when you share with the IT people, they understand and they don't feel scared when you want to implement the audio network audio in their existing infrastructure. So sharing this information make them comfortable, which is very important. Otherwise, IT people don't want to mess up with their infrastructure or their setup. So they are always hesitant. So sharing such knowledge will make them comfortable, and you can have this smooth installation and setup for audio system. Now let's go a little more in detail about Dante. So here we're going to talk about flows and channels. Yeah, let's talk about this. So what is flow? Flow is a sequence of packets sent to an IP address. In this slide, you see there is a trolley, right? So consider it's a Dante device. So one Dante device is like one flow, and one flow can have 4 channels or one channel, still considers as one flow. Yeah. So if you are having a Dante device and it offers 4 channels or 5 channels, whatever. So even if you are taking one channel from that Dante device or 4 channels, it is going to consider as one flow. Yeah. So let's go a little bit in detail about flows. So Dante groups audio channels into flows. By default, all flows are unicast. So I'm sure you understood what is unicast, multicast, and broadcast. So Dante by default offers unicast flow, and each flow supports up to 4 channel, and maximum number of flows varies by the chipset. So as said, Ordinate offers the chipsets, and different chipsets are having different number of flows. So I'll give you an example here. Consider your means the system what you got is having Ultimo chipsets. So Ultimo chipset offer you 2 transmit and 2 receive flow, right? And if the system is having Brooklyn 2 chipset, then it offers 32 transmit and 32 receive flow. So talking about Shure products, MXA310, NE4N, NE4 route. I'm hoping that you know this model number. Otherwise, we are going to have a different webinar where we'll talk about these products in detail. So MXA310, NE4N, NE4 out are having Ultimo chipsets, and Ultimo means it offers 2 transmit and 2 receive flow. And ULXD, SCM820, Microflex wireless interface, NE, and MXA910 supports 32 Brooklyn 2 chipset, and that offers 32 transmit and 32 receive flow. Okay, now I'm going to give you an example here with the setup. So consider, and I may ask you questions over here, and we are going to have the poll here, so that you can also contribute in this session. So have a look on this slide. You're having MXA310 connected with the network switch, and audio is flowing with, the channels are flowing with unicast flow, and you have 2 receiver, yeah, NE4 out, which can accept Dante and convert in analog, offering 4 channels from both the flow. And here you're having 2 receivers, right? Now, my question for you guys is whether if you want to connect the 3rd receiver over here, will it work? Let me start the poll. Or, yes. So can you please connect? Can you please answer? I believe you guys are getting the poll asking, can you connect more than 2 NE4 out? Yes or no? So I'll give you 1 minute to answer, and then I'll skip to result to see what exactly you understood with the flows in Dante. Okay, so let's look on the answer. Let's see what have you answered. So skip to result. Awesome. So 60% say that yes, you can connect. Can you connect more than 2 NE4 out? So 67% is saying yes, and 33% is saying no. So great. Thanks for sharing. So let's understand over here. So as I mentioned in the previous slide that uh, MXA310 is having Ultimo chipsets and NE4 out is also having Ultimo chipset, right? So NE4 out, MXA310 cannot have more than 2 transmit flow in unicast. So when the first flow received by the first NE4 out and the second flow received by the second NE4 out, your flow is over. The MXA310 flow is over. And then the moment you connect the third one, it will not go through because we are talking about unicast flow and both the flows, transmit flow of 310 are occupied, right? So the audio will not go through. So those who answered no are right. Okay. Now let's move to the next uh, uh, broadcasting, next transmission method. So now if you are having a multicast flow, so the question over here is whether we can have the more than 3 NE4 out connected with that to receive the signal audio channels. So here it is going to be yes, because multicast is one to many. So you can, if it is about transmission side, you can have the multicast flow in Dante controller software, and you can have multiple receiver to receive the same audio packets from the transmitter, which is MXA310, right? Why? Because it is in multicast. You're just utilizing one flow in that case. Now let's move to, I hope I'm clear. Now let's move to the next slide. Now I'm going to have another question here for you guys, and we'll create a poll. Okay. So here you have a network switch, one MXA 310, first flow, then second MXA 310, second flow, then you're going to have third one and fourth one. Now let me explain what is NE4 out. NE4 out can have 4 Dante input and it can convert in analog, right? So the solution, what is showing here is you're having 4 MXA310 and somebody wants to connect with NE4 out. Now the poll over here is, can you connect these 4 MXA310 to one NE4 out? So you guys got the poll, the question here. Can you please answer and then we'll talk about this? I'll give you 1 minute for this. It's simple. It's all about flows. One flow is one network device, one Dante device, right? 20 more seconds. Okay, let's see the result. So again, 79% are saying yes, you can connect, and 21%, okay, it's still going on. Poll is active. We can stop the poll now. And 78 and 22%, 22% are saying no, you cannot. And yeah, that's the right answer. You cannot connect all four MXA310 with one NE4 out. Same, because NE4 out is having maximum 2 flow of receiving, right? So when you connect the first one, right, I'm going to take you, so it is not going to connect more than 2310. So let me take you to the next slide and explain. So when you connect the first auto mix output of MXA310, so that's consumed by first unicast, second by the second one. The moment you connect the third one, the NE4 out is going to block those channels, those audio packet. Why? Because NE4 out is only having two receive flow. So it can only accept two Dante-based network devices, right? So you have to be careful when it's all about the game of flow. So you have to be always careful what exactly you are having as Dante receive device, what kind of chipset is there, and then you should design. Otherwise, you will end up thinking that, oh, it is having 4 Dante inputs, so it will accept all 4 channels, and then you will end up in a situation where it will not work, and then you need to look on plan B. So what is the solution in that case? You need to go for other kind of audio breakout box or audio network interface, something like MXW-NE. So MXW-NE is having Brooklyn 2 chipset. So you can have 32 transmit and 32 receive flow. So it can accept all 4 flows by routing it through Dante controller. Yeah, so that's what you need to understand when you design the Dante-based system. Now let's move to the next topic, AES-67. AES-67 is an open standard. It is not an, it is, okay. So AES-67 is an open standard. It is not an audio protocol. It's a standard which provides the interoperability between layer 3 protocols. So when we say layer 3 protocol, it falls under Dante, QLAN, Ravenna. So Dante, QLAN, and Ravenna are layer 3 protocol. So even usually what happens if you're having a receiver and Shure microphone which supports Dante, you need to have Dante card in your receiver to receive Dante signal, right? But if you're having a receiver which supports QLAN or Ravenna, you can enable AES67 standard in that device, and you can enable our Shure devices for AES67, and you can have the audio packet transmission with AES67 standard. So you don't need to buy additional Dante card for your receiving device. So you can utilize AES67, and it only works for layer 3 protocol like Dante, QLAN, and Ravenna. Our MXA910, Microflex Wireless, ULXD, right? These devices supports AES67. Okay, so that's just for your knowledge in terms of thinking about designing the system. Now let's move to the next topic. The next topic is switch configuration. Okay, so we always recommend, whenever you're having Dante-based system, we always recommend to use a managed gigabit switch with power over Ethernet. So managed, so you can control the settings of the network ports. Gigabit, so that it has plenty of bandwidth. Power over Ethernet, so it can power the devices. Most of our Shure network devices are working on PoE, power over Ethernet. So having that solves that problem. So we always recommend to have power over Ethernet based switches. In terms of switch configuration, we recommend to disable energy efficient Ethernet. So there are many switches which comes with this feature. It's not a kind of demerit. It's a feature of network switches nowadays. But what happens if the specific port is not getting used by the switch? It goes in power saving mode, and which is not good for audio. Having a millisecond of a delay or latency in audio can also be noticeable. So we always recommend to disable energy efficient Ethernet feature from the network switch. Nowadays, the switches are having web GUI. You can go there and disable this feature. We don't recommend for Dante. Verify multicast capability, which is required for discovery, clock sync, and AES67 standard, and configure IGMP snooping if necessary. You want to know about more? You want to know more about IGMP? You can go to Shure FAQ and find out. Yeah, but I'm going to quickly explain what is IGMP. So IGMP is Internet Group Management Protocol. It's a protocol of network layer. It's a network layer T protocol and used by host and adjacent router to form multicast group membership. Yeah. So that's IGMP. Now you will ask, why do we need to know about this, right? So let's talk about this. You don't, but consider this. You're having a switch connected with multiple network devices. Switches flood multicast packets out of all ports. So when there is no multicasting configured in the switch, at that point, when the host want to send the audio packets or any packets in the network, then if you're having multiple network devices connected, it broadcasts and goes to all the active ports. So that creates the floods in the network, right? So multicast traffic creates unnecessary network congestion, right? And forces devices to work harder, discarding unwanted packets. Okay, so that creates network congestion, which is not good. So you must have noticed sometime that network devices are getting hanged, it is not communicating properly. So all these happens if the switches are not configured properly. To give you a graphical representation of this IGMP, consider you're having this scenario. You're having your switch, you're having router, you're having your PC device for control, and a couple of audio devices all together, right? When the IGMP is not configured, what happens, multicast traffic is sent to all the active ports, which creates unnecessary traffic. You see, the PC is sending the packets to the Shure receiver, another DSP, and the mixers. So it creating unnecessary congestion with the network. But when you are having IGMP enabled, yeah, so devices join multicast groups, right? And multicast traffic is only sent to member of the group. So now, if my Shure receiver wants to communicate with the mixer over here, so it is showing in blue color and it is just sending the packets to that specific receiving end. And talking about PC is going to have control and audio both options. So it is having the capability to have the audio packets or the data to travel in all different network devices connected. So it is only going to send to the network devices which are required to receive the packets, and it makes it a much better. Unnecessary network congestion go over. Yeah. So that's all about IGMP in a nutshell. But you don't need to have IGMP all the time. For a simple configuration, we recommend to disable IGMP snooping if network congestion is known and static. It is if the network is not managed by IT staff, no high data rate multicast traffic, or you have dedicated AV only network. Otherwise, consider IGMP snooping, and in that case, the switch must be configured properly. You talk with IT staff to do the proper setup and consult AV manufacturer for setup info. Yeah, so that's all about IGMP. Now let's move to the next discussion. We are talking about networked audio, digital audio, right? So networked audio moves bits 1 or 0, right? It's all about 0 and 1 in digital system, regardless of what kind of packets are getting sent. So either it's a sound signal or the image or email or Facebook post. Yeah. So when everything is in network, you have to prioritize which data is most time critical, right? Imagine if you have this scenario, if you sent an email to someone, right, and the recipient received it in 2 minutes, it's okay. they can read that email after that. If you are posting something on Facebook and your wall is showing after 10 minutes as well, you will get the same number of likes what you're going to receive in 10 minutes prior to that, right? Because it's all about the post and people will see and respond. Now imagine you're having an audio file, audio packets in the network, and you receive after 2 seconds. You will not accept it. Everybody will notice it. So it is very important to prioritize the time sensitive packets in the network. And to do that, switches are having the service called QoS, quality of service. So what is quality of service? Quality of service is a packet prioritization tool in switches. It is useful only when the network is slow, for example, 100 Mbps switch, or very heavy loaded network, like 350 channels of audio on one link. Yeah. How does the QoS work? So the data with tags marked for high priority are pushed to the front of the line. So it prioritizes which one is having the time sensitive, which are the time sensitive packets in the network. And Dante packets contain QoS tag. So you can define quality of service for Dante packets, and it will take care of the prioritization of time sensitive packets, audio packets in the network. So having QoS helps. So always consider having quality of service if having Dante packets in the network. Other configuration, what you can think about in switch is VLANs. VLANs are basically easy way to separate audio from control and other traffic. VLAN must support multicast and provide sufficient bandwidth. The only downside of VLAN is you have to have a lot of integration with other network services. Yeah. So knowledge is the must to have the proper switch configuration, something like VLAN, QoS, and IGMP. To summarize the switch configuration topic, if you go to our website, you can search Shure disqualified switches, FAQ, and over there you will get a list of undisqualified switches. And those, most of the switches are just because those are having EEE energy efficient Ethernet service feature built in, and you don't get the option to disable it. We don't want EEE feature enabled for Dante based network device switches. Yeah, you need gigabit managed switch with power over Ethernet and disable IGMP snooping on a small network, right? So now let's move to the next topic. Based on our experience, we see top 5 problems when we deal with networked audio. So those problems are like devices, computers are not on same subnet. So always look on IP, look on the subnet configuration to understand if you are on the same subnet or no, and change accordingly. Unqualified switches not configured properly will become another problem for the network system. Network-based, Dante-based network devices. Firmware versions are not compatible or updated. Application not up to date and allowed through the firewalls. Look on the firewall setting. And fifth one is faulty cables. Yeah, that looks pretty like what? Faulty cables? Yes, it can also have the problem because of the faulty cables. There is no harm checking the cables as well, right? Now, tools what you need from Shure or for the networked audio based system, you should have, if you're dealing with Shure products, you should have Shure Device Discovery app. It's a discovery tool to discover all the Shure network devices, and it works on it is having cross subnetting feature. So even if you are not on the same network and you're having Shure devices connected, it can show with different IP address. So it's just a matter of changing the IP address and connecting with the Shure device. So Shure Device Discovery app, which you should have. You're not going to lose any Shure network device if you have Shure Device Discovery app, because it discovers everything regardless of having on same network or not. The second tool what you need is Shure Update Utility app. Shure Update Utility is a software tool to upgrade or downgrade the firmware of Shure devices. Dante controller is a software to route the audio from transmit, for example, Shure, to receive any mixer or DSP audio devices. Yeah, an optional Dante Virtual Sound Card software. Dante Virtual Sound Card is the software tool which enables your laptop to act like Dante device. So you will get Dante receive and transmit uh, channels by having Dante Virtual Sound Card. It's a license-based software. You have to pay $30 to get that. Yeah, but it is recommended if you want to have, if you're having software-based conferencing codecs like Skype, BlueJeans, Teams, and you're having one laptop which needs to be connected with those calls. So having the audio directly from the Dante-based microphone becomes easy, yeah, by having Dante Virtual Sound Card and all. So that's all about it. Um, uh, hope these information are going to help you. If you guys are having any question, feel free to ask in Q&A box. We are here to answer all your queries, and then we can end this course. And we are going to have our next session next week at 12 p.m. same day, Wednesday. So stay tuned for that. Thank you very much, guys, and stay safe. Take care.